Yes, dear students, good morning. Students who are in the online, am I audible? Okay. So last class, what we discussed? Come on, fast. NumPy iteration. NumPy iteration we did with one-dimensional, one for loop, with a two-dimensional, two for loops. The first for loop deals with rows. We're sitting in the chair and then moving the hands like this, legs like that. Maroon color t-shirt. Stand up. Two-dimensional array, how do you display? How many loops? Two loops. Inner for loop represents what? Inner for loop. Inner for loop. I changed my question. Outer for loop deals with what? Rows. So you are sitting in the chair and moving the legs like this, like bus passenger. Sure. Now, come to the point of it. Multi-dimensional array. Multi-dimensional array. How many loops? Three loops. Outer for loop deals with matrix ID, matrix index. Second for loop, rows. Third for loop, columns in the row. You know, all those things. Right, students? I hope maybe last class, we already started with topic called what? So that is example on NumPy iteration. Example on NumPy iteration. This was already in the progress, right? This was already in the progress. Okay, students. This was already done. This is a single for loop. Done. Get it? This is a with while loop I said. This is a heading is examples and NumPy iteration. Even concept also I will open it. Go to KVR NumPy. Under that notes, NumPy it. So where is it? Here NumPy array iteration. So here by using what? Loops. By using loops, I put it heading actually. That will be done by using for loops, while loops. That is one thing. One more is by default today we are going with the loops you did. Now there are two functions I said. One is called what? Enumerate and iter. But here nd iter and one more is nd enumeration. Enumerate. Now I'm going to take up. This already we did, students. This is a three-dimensional matrix. Already you are well aware of it. I need not to repeat again. This is just in a glance. Single for loop for one-dimensional. This is a while loop also written. While loop also written. Shape of 4, 4 with what elements here? 4 by 4 elements. 4 rows and 4 columns. 2 for loops I used it. 2 for loops I used it. Now I am having 16 elements in that form of 3D. 16 elements in the form of 3D. This is the one having 3 for loops I used it. So we already done in our classes. ND, that is NumPy iteration. Iteration, important students. This is a regularly coming requirement. Number one by using loops. So you have seen by using what? 1D for value in what object? ND array object. And you have written some statement, correct or not? This is the data. You have written some block of statements. One more is what? 2D. What are the things written for a row in where? ND array. Inside of that what? For column value in where? Row. and we wrote certain statements. We wrote certain statements. Did you remember, guys? Next is called 3D. 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 What is that 3D says? For matrix in ND array. Very good. Come on, next. For row. Very good. Matrix. Come on, ma. For column value in where? Row. Very good. So it is called what? Some statements. Some statements I'll write it. These are comes under, come in, ma. These are comes under 3D. If it is a 4D, cluster ID. Cluster ID contains matrix. Matrix contains row. Row contains column value. This is called what? By using loops. Is it easy or difficult? Come on. Easy. No doubt in that. But when you see the most easy of this one, still it is going to be dead easy. Instead of writing 3 for loops, some people may not be knowing how these loops are executing. This will execute for number of times, then it will go to this place. This will execute number of times, this will go to this. Since you already learned in my class loop in a loop very perfectly, this is today dead easy. And there is no doubt in that. If you take any other student, they don't know how these loops are executing. But that's why, especially in NumPy, especially in NumPy, we have two functions. We have two functions to iterate the elements of what? ND array. ND array. What are the two functions, ma? One is called ND iter. ND iter. Second one is called what? ND enumerate. Enumerate. That also you know in my class. Iteration means what? Repetition. What is this ND? Actually, enumerate will give you what? Index value. Index value. Index value. But we are using what? ND. I'll show you both of them. Shall I go for ND iter? Yes. Simple, students. As usual, I will say today NumPy as NP. NP A is equal to NP dot array of, I am going to take up 100 comma 200 comma 300 comma 400 comma 500 comma 600 comma 700 comma 800 comma what? 900. For example, I want to print this data. Print this data. Type of A. Done. Now I got this data. How you can do this data? Simple, students. For value in NP dot, come on, ND iter. ND iter is a function present in where? NumPy. Of what I will say? A. A. I will write what here, students? Print of what? Value. Print of value. So is it not getting the data like this? Are you getting or not? So here I am using np.nd iter of A. Which type of dimension it is? Display the elements of what? 1D array. 1D array. 1D array. By using what function? ND iter. Earlier by using what? Single for loop or single while loop you used it. Even this also, no need to use what? ND iteration value like this. ND iter, you are using like this. Simple now? Now, for 1D is concerned, either normal for loop, this is simple, no problem. Let us go to the same place. I will take this data. In this place, I am going to take up. Then since it is 1D, what I do here? A dot shape is equal to 3 comma 3. Correct? 3 comma 3. See, this is called what? 3 by 3 matrix. Now I want to display the data. How do you display the state data, students? Come on, ma. For directly value in NP dot, come on, ND iter of A. A. What is this now? Print of what? Value. Value. As usual, you are getting the data as it is. What is reduced? For loop in a for loop, that complexity of looping execution is done. So ND iter will get all the elements as a flattened list, and displaying the data. I hope you are following me. I hope you are following me. Are you getting, students? This is displaying which data, students? Displaying which data? 2D. Displaying which data, guys? 2D. So here I am writing displaying 2D. Got it. Done now? Next I want to go for 2D. 2D by using which function? NumPy dot ND iter of ND array object. ND array object. ND array object. By using this also I will keep it aside. Here also I will write like this. Okay, students. Now I'm going for one more discussion. One more discussion I just want to go for it. So the another discussion I am looking is something like this. 3D I want to go for 3D. Same thing. I will go for this. Here I am going to write it. Writing, comma, 150, 250, like that. And next to 450. How many elements? 12 elements. What is this now? 2 comma 4 comma 2. 4 comma 2. Are you following? How many matrices? No. 3 comma 2 comma 3 or 2 comma 2 comma 3. Anything is okay, na? Right. What are the total elements? 12. Come on, fast. 12 elements. 12 elements. 2 matrices. 2 matrices. Each one is called what? 3 rows and 2 columns. How do you display this data? Same. Same to same. No changes at all. So I will go for what? As it is. I'll go for what? 3D. 3D by using what? ND array object. Same A only. So this is going to getting. So I need not to write what? 3 for loops. Need not write 4 for loops. Is it not reducing the work? So which one is better? NumPy dot ND iter of what? ND array object is always better. Understand, students? Very good. Now I'm going to enter one more function called what? Enumerate. Because of that, I'm getting only values. Sometimes I'm looking for indices also. Indices also. How to get the indices also? My dear students, go once. Here I will show you. Of course, I shown you already in my regular classes enumerate function, but still I am showing for other students. Suppose I am taking LST is equal to 10 comma 20 comma 30 comma 20 comma 30 comma 60 comma 70. This is my data. For value in LST, for value in LST, print of value. This is coming. Very good. But I want to know about index also. Index also I want to print. How do you print the index, students? Enumerate function. How enumerate function works, I already said. Once again, for other students, I am saying. Enumerate is a function which will take any iterable object which contains more than one thing. Enumerate function will prepare a table of values, my dear students. One is called what? Index, and one more is called what? Value. This is called index, and this is called what? Value. 0, value 10. Next is 1, and this is 20. Next is 2, 30. Like that, I am going to take all these elements. Like that, I am going to take. These are all called indexes. These are all called what? Values. How do you take it now? I am writing index comma value in enumerate of what? Any iterable object. Here I will write it simply I will write like this dot format of index comma value. Index comma value. Is it not printing the indexes here? So the specialty of enumerate function is it is going to give you the indexes. Along with that, what will come? Values also will come. Same thing we can apply here also. Let us go to the place. As usual, students, I will take my elements. Come to the point back. I'm going to take up very easy, no shape, nothing. Just I'm taking like this. Are you following? What is the dimension, ma? Come on. Print of a dimension, just for a dimension. I'm just going to write it. There's a meaning. Dimension of A is equal to comma A dot ND. A dot ND. Now I'm going to print. Come on. Index, comma, value in NP dot ND. ND. Enumerate. What is the meaning of ND? one dimension, two dimension, any dimension of what? A. See students, print of, I'm going to write it as usual. I'm going to write it dot format of, come on, index comma value. If you are interested to value, I'll go for this now. If I just say that it is saying 0 comma 1 comma 2 comma 3 comma 4 comma, all the elements are coming or not? Able to get it or not? So the speciality of this place here, what? Indexes are going to come and the values are coming correspondingly. This is called what function? Displaying which elements? Displaying which elements? One dimensional array. 1D array by using what? ND enumerate. ND enumerate, I am going to use it. Now, coming to the point of it. So, can we start indexing from 0? So, Jadhav, my dear student, indexing starts in Python from where? 0. That I already, there is a standard designing policy of Python. So, indexing cannot be starting from, yes. If at all you are interested to go for what? Programmatically, if you are very much interested, if you want programmatically, if you want that style, you can go for what? Index plus 1, you can say. So what is coming? Error is coming. If you write index plus 1, what is happening here? It is going to give you this error. So can only concatenate tuple with this kind of thing. You cannot write this index plus 1 here. Are you able to follow? So it is not possible because it is going to contain indexes of what type? First of all, tuple type. To the tuple type, if we write, we will get what? Error. That is, tuples list will not perform vector based operation. Single value addition is not possible. I hope you are getting it. So it is not possible. If at all you need, I will go just to go for what? 0 plus 1. You try to say what is happening. See. Index of 0. What is the index of 0? 0 plus 1. 1. Next is what? 1. 1 plus 1. 2. Next 2. 2 plus 1. 3. Are you getting? Subject. Once you have subject, you can do anything. Regular dialogue. Rubber band example. So are you getting this? Like this. This is called what? Programmer defined index. Programmer defined index. Jadhav, I hope you are following me. My dear student, got it. Yes. Are you following? But a default index is like this. Super. Go to next part. I'm going to introduce another part of it. Go to where next? 2D. So this is my elements here. I'll say a dot shape is equal to 3, 4 or 4, 3. Anything is okay now? 4, total 12 elements are there. 4 rows and 3 columns. And try to print the dimension also, my dear students. Dimension also you print it. Dimension also. Now you print what you know? Shape. Shape is equal to what you can say? A dot shape. A dot shape. And you got the elements like this. Are you following, guys? Now I'm going to take up. Be careful, ma. Now I'm going to write it. Same to same here. The earlier one I will take it. This one I will take it. This one I will take it. Carefully try to follow. Here I'm going to say display what dimension array? 2D array by using enumerate, nd.enumerate. Please try to follow. See, my dear students. As you already know that 0, 1, 2, 3. 0, 1, 2. What is this? 100. 0, 0, 100. 0, 1, 200. 0, 2, 300. Are you following that? So next is called what? So next is like that. 1, 0. What is that? 400. Something problem? So here, no problem now. So like this, you are getting it. 0, 0. It is going to give you like this. All the values are going to come. So these are all called what? These are all called what? all the things are coming. These are all called what? Columns. All the values are coming. This is comes under what? Come on. 2D array. 2D array. Shape is called what? 4, 3. Understand? 0, 0, 0 first row. 0, 0, 0 first row. 1, 1, 1 second row. Third row. And this is called fourth row. Got it, guys? Well, now I'm going to take up. Now I'm going to take up one more kind of thing. I'm going to say something like this. What is the next one I'm going to say? 3D. 3D, I want to go for it. Same thing, 3D, I will go for it. As usual, go to this place. Here I'm going to take up, tell me, what is this now? 2, 3, 2, 3, 2. A dot, dimension, shape, everything. Getting or not? Now, what is this now? 0, 1. What is 0, 1? Matrices. 0, 1, 2. 0, 1. 0, 1, 2. 0, 1. What is this now? 0, 0, 0. 0, 0, 1. Next what? 0, 1. 0, 1, 0. You know the total story. You know that everything. Now display. How do you display? Same to same. Same to same. Instead of writing 3 for loops, I'm just completing the things with what? Simply 1 for loop. So same ND of this same thing. You see, my dear students, already you know 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 2, 0, 0, 2, 0. This is for what? 0th matrix. For first matrix 1, 0, 0, 1, 0, 1, 1, 1, 0, like this. Are able to get it? This is called which one? 3D. 4D also you can go. I hope you understood. Difficult, huh? Easier. Easy. Are you practicing daily, first of all? Yes. So how many ways are there to iterate my ND array? 2 ways. By using loops. By using ND iter, and one more is ND enumerate. ND iter will give you only elements showing without writing lengthy code of for loops. With enumerate, I will get indexes also. That is the speciality of that. If anybody asks what is the difference between ND iter and ND enumerate, will you answer it? Very good. This is related to NumPy iteration. Okay, na? Very good. Now, I want to enter into something more, because I will take you almost to the data science. Now I go to the place. Now I'm talking about how many types of distributions you know. Normal distribution, uniform distribution. Uniform distribution. What do you mean by uniform distribution? Uniform distribution. The values are close to each other. And you know, the discussion already done. What are the functions we learned? Random dot rand. Random dot rand. Next, random dot uniform. That are called what? Uniform distribution. After that, uniform dot random dot random. 1 minute ma. Random dot rand. Next, random dot random dot. Very, very important. Random dot uniform. Both of them deals with what? Very good. Uniform distribution. Uniform distribution. So, uniform distribution. Data visualization also I will show you. Nothing to worry. So there are a lot of things to discuss with you. Random dot. Yes, rand n. That n stands for what? Good. So, random dot next. Normal. Yes, normal. Very good. Normal. This deals with what? Normal distribution. So, normal distribution. You already know how the visualization is. Maybe you have the type of small awareness in your brain, right? Now there is one more small concept I want to tell you, which is important, which is an important, that is data distribution. Data distribution, very, very important. Data distribution in NumPy. Data distribution in NumPy. What do you mean by data distribution? Data distribution is nothing but possibilities of occurrence of values in a list. Data distribution is nothing but possibilities of occurrence of values in the list or ND array. Spell out once. Possibilities of occurrence of values in the list. Once again, I want to get it. Possibilities of values of occurrence in the list. So that is called what? Data distribution. Here, I want to come to occurrence of the value. Very easy. Some of the one girl is looking here and there. If they don't know English also properly, we will look here and there. Now, what is meant by data distribution? If I ask a question, they will feel. If I don't ask question, I will feel. That's why be careful. Actually, girls are in my soft corner actually. Boys are in my front corner. If something doing wrong, fire. Because you need a job. Girls also need a job because they're sincere already. Boys also sincere, but I want to see always to your sincerity. Let leave that part. Data distribution means what? Possibilities of occurrence of value. Okay, good. Now I am asking a question. Suppose one more terminology I want to introduce. Probability. Do you know probability? Do you know? You don't know. Suspension, no. You know, you don't know. Huh? Don't know. That is called what? Zero occurrence. Zero occurrence means never happen. You know, you don't know. Suppose if I say I know, it is called 1. Probability of knowing is what? 1. Not knowing is what? 0. So 0.2. I know probability. See, this is very important. This is very important in data science. Actually, I want to teach probability completely. If I am teaching data science, probability I will teach almost 12 days. And you learned in intermediate. You learned in intermediate. Intermediate, how you learned, you know. How I learned, I also know. But when we enter into data science level, of course, myself felt one day, see how learn intermediate, how we learned here. Of course, in intermediate, we learned very well. But that basics, that good teaching of experts is really helping. Now I will give you simple explanation you will follow. I know something I'm explaining. I know 0.3, 0.3 concept. I know 0.3 level of probability. For example, level of probability. I'm not explaining completely. I'm not going to spend with you probability of this 10 to 12 days. 0.2 level of probability means what? Probability means what? What is the meaning of this 0.3 level of probabilities? First of all, 0.3 means what? 3 by 10. This you know now? Ante? This you mean, this meaning you learn, it is more than enough. Out of 10 times, out of 10 questions, if I ask, you will answer 3 times only answers. That is called what? 0.3 probability. Got it up? How many times you cannot answer? 0.7 times you cannot answer. Did you understand? 0.03 probability meaning is what? 3 by 100. 3 by 100. How you know this 100? Dot. 2 zeros you write and 1 you write it. That is nothing but if I ask 100 questions, you will answer how many? That is known as what? 0.03 probability of occurring that value in my data distribution. Did you understand? Now, the probability will be always either 0 or so probability lies between what? 0 to 1. Understand, my dear students? So now I am saying, take a list here. Directly I am coming to example. No problem of entering all these things. Suppose there is a value called I. There is a value called I. I am saying that I occurrence is 0.5. 0.5. What is the meaning of that? Out of 10 times. అక్కడ చూడండి అమ్మా 0.5 means what? 5 by 10. Out of 10 times. How many times that chance of occurring that value? 5 times. 0.3 means what? Out of 10 times. 3 times occurring of the chance. 0.25. What is that? Out of 100 times. 25 times there is an occurring of the value called I. And stand up. Come here. And you are sitting so nicely, and your ornament, you keep it in the packet first. That ornament, keep it in the back. And sleeping, the way you are sleeping, I'm just wondering. Journey, whatever it is. Journey means take rest. And why that ornament, journey and all? Listen the class. Don't sleep. Now, what is the probability of sleeping in the class? 0.9 times. And out of 10 members, one person is compulsory sleeping. You don't feel it. I'm expressing my, otherwise I'll feel tension. I have to release my tension by saying this example to you. First, listen the class. Now, are you able to follow? So, what is the probability range? 0 to 1. Suppose, for example, my probability of sleeping is 0. What is that meaning? Sleep never occur when I am in the class. Are you following? Yes. A driver is driving a car. These are all called problem solution. A driver is driving a car and the possibility of sleeping is what? Probability of sleeping is 0.01. What is that? Out of 100 kilometers, there is a chance of sleeping at 1 kilometer. That time we will take the rest. And these are all called what? Avoiding the fault tolerance of mishandling the driving. And these are all called models which are coming in data science level. My dear students, I hope you are getting the probability now. This is known as what? Probability density function. Spell out. Probability density function. For example, now I am taking one list is equal to 2, 5, 6, 7, 8, for example, or 2, 5, 7, like this. For example, 2 occurs in data distribution with a probability of 0.3 times. What is the meaning of it? Out of 10 times, my 2 will come how many times? Yes. Next 5 occurs 0. What? 5 times. What is the meaning of it? If I run my application 10 times, 5 will come how many times? 5 times. Next up, 6 occurs 0.2 times. What is the meaning of it? If I run 10 times, 6 will come how many times? Very good. Now 7, now tell me, occurs 0 times. Why 0 times? My probability 0.3, 0.5, 0.2 gives you what? 1. Then 1 probability means where is the question of next one? 7 will not come. That means even if I read 1000 times, 7 never occurs. This type of thing is known as what? Probability density function. Spell out. So do you understand the data distribution? In my data distribution, I am specifying 3 occurs 0.3 probability times. 4 occurs 0.6 times. Something I will write it with a probability density function. I will mention it. For doing this kind of things, we are using one function, student. What is the function now? Random dot choice. Spell out. Random dot choice. Random dot choice. What it will take, students? ND array object. ND array object. Probability function P. P represents probability density function. Is equal to, I am writing 0.3, 0.5, What is that now? 0.2 comma 0. What is my ND array object? For example, here I am writing 2 comma 5 comma 6 comma 7. 2 comma 5 comma 6 comma 7. Probability is equal to size is equal to 100. I am writing size is equal to 100. What is this now? 100 values I want. 100 data distribution I want with what possibility density functions. 2 should come how many times? And out of 10 times how many times? 100 times? Yes. 5 will come how many times? How many times here? Like that, like that, like that. Which one will not come at all? 7 will not come at all. Are you following me? Similarly, this is for what? 1D probability, 1D data distribution. 1D data distribution. I am going to write next word 3 comma 5. What is that 3 comma 5? 3 comma 5. 3 rows, 5 columns of with these elements only, with these probabilities. Are you following? So manually you may not be able to write. My choice function will take care about all these things. My choice function can take care about all these things. Are you understanding the meaning of data distribution? In data distribution, what is the most important? Probability density function. Spell out. Probability density function will tell what type of occurrence the value must repeat. 0.3 times or 0.2 times or 0.0223 times or what is the meaning of it? Occurring, are you following, students? So you already know very well in your basic level, P plus Q is equal to what? P plus Q is equal to, sorry, what is that? 1. P is equal to what? 1 minus Q. What is this? P says occurrence. 1 minus Q says value not occurrence. Occurrence chances, not occurrence chances. P means what? Possibility and not possibility. What is this now? 1. 0.5, 0.5. The chance of getting the job, I can say 100, I can say 1. Why? Daily I will read morning to evening because there is no question of not reading at all. So you are giving 100% to your parents. Probability of my job is called 100% I'll get. 1% you are saying. Somebody is saying, I may get it, I may not get it. What is the probability of getting job? 0.5. Not getting. So 50-50 chances. That is nothing but what? 0.5 plus 0.5. So you have to increase your occurrence of the value maximum times. Are you getting, students? Now coming to the point back. Now I'm going to show you one small documentation for you. So follow me carefully. Online students, are you able to understand? Are you able to understand a small discussion here? In the random, I said what is the function name? Choice. Choice. Come back. Here I'm going to say what is that concept is called? Random data distribution. A small concept I prepared it. Now carefully try to follow. So all of you try to read. Read ma. The data distribution is a list of possible values and how often each value occurs. Such lists are important when we are working with the statistics and data science. Did you understand? How often the value occurs in the data distribution. They are important in our data science. The random module offers methods that return randomly generated data distribution. Which function will? Choice. Choice. Rand, rand. Uniform and then what? Normal. That is also going to be generating the random values only. That is called what? Uniform distribution and normal distribution. This is called what? Data distribution. Come on. Random distribution. A random distribution is a set of random numbers that follow certain probability density function. Probability density function. Here I am going to tell you the probability density function definition. A function that describes continuous probability means that is the probability of all values in array. We can generate random numbers based on defined probabilities using choice method of random module. Method or what? Function. If it is OOPS based programming, we call it as a method. If it is a functional based programming, we call it as function. The choice method allows us to specify the probability of each value. The probability of set of a number defined between 0 to 1. 0 means value will not occur and 1 means that value always occur. Example, generate 1D array containing 100 values where each value has to be 3, 5, 7, 9. The probability of value to be is set to be 0.1. What is the meaning of 0.1? Out of 10 times, 3 will come 1 time. And if I run my application 10 times, 3 will come how many times? 1 time. That's it. The probability for the value 5 is set to be 0.3. Out of 10 times 0.3. Don't come and ask me, sir, how you got 10? Because 0.3 means what? 3 by 10. 0.33 means what? Out of 100 times, the value will come 33 times. I hope you got it. Right, good students. Now, the probability for the value 7 is said to be, is it becoming 1 or not? The probability of 9 is said to be 0. 0 means what? Never occur. Example, quick example. From NumPy, import random. You can also write like this. From NumPy, import what? Random. What is this NumPy dot import random module? From NumPy is this. And random dot choice. Random is a module, choice. Or you can write what I already said to you. Or import what? NumPy. NumPy. If you write like that, as NP, you can write what? NP dot random dot choice. Because already you know in our class 7 syntaxes of import statements, from import, important, etc. So now I am saying random dot choice of your list object, ND array object, whatever it is, P is equal to 0.1, 0.3, 0. These are all called a probability density function. And size is equal to what? 100. Print of X. The sum of all the probability numbers should be 1. This sum I am talking about it. Even if we run the above example 100 times, 9 will never occur. Why? Whose probability is what? 0. You can return array of any space and size by specifying the shape and then what? Size parameter. My dear students, I will carry this example and I am going to write it. Random data distribution is my example. I'll go to this place. I'll save it. Important, very, very important. If you go for regression analysis, random distributions in data science, just if you open it, follow my documentation immediately. So I'm going to take up here. I'll give my file name. So examples on NumPy, random distributions. So which function I am using? Choice function I am using. Very, very important. Here I am going to write it. Import what? NumPy. As what? NP. Right. Now I'm going to take up the data. Here directly I will write it. Go to this place. In your level of understanding, I will write what? NP dot random dot. Here there is a value. If you want, you can convert into what? You can say. Simply you can say A is equal to what? NP dot what? Array of, what is this? List. And you print this. How many times? 100 times. Be careful, my dear students. You can count it. What is this now? Print of what? X dot. What is this now? Size. X dot size. How many times? 100 times it is available. You can happily count this part. Possibility of occurring, I am writing this time. So here you just try to see. Are you able to follow, students? You try to go on running it. It's the probability of giving something like this. Are you following? So you can go for counting all these things. The probability is mentioned 0.1, 0.3, 0.6, something like this. Able to understand? In this case, you see 9 will not occur. I'm not explaining complete probability. Actually, probability, there is so much discussion is there. When you enter into the data science level, there probability will come, integration will come, differentiation will come, not mathematics related, application based will come. Today I said 0.3 probability, you can understand the meaning of it. Similarly, you can go for what? You can go for what here? 2D also you can display. What is the 2D here? Tell me students, what is the 2D here? Come on. I am going to write 3 comma what? 5. You just try to say here. Try to say 3 rows and then what? 3 columns. So 5 columns. 5 columns. I hope you are following. So don't think that 3 will come only one time. Probability of occurring is 0.5 means what? If I go on running, it may come one time. It is going to be displaying like this. So next, I can go for giving you what? I can go for giving you what? Like this also. What I am going to say? 2 comma 2 comma 2. 2 comma 2 comma 2. It is also going to be given something like this. Probability of 3 is coming how many times? One time. Are you able to get it? So if we go for still probability level, it is going to be dead easy. So the main intention is to tell about which function? Choice function. So choice function, data distribution mechanism, random data distribution mechanism. You can define the occurrence of the values. This probability will be coming in data science learning models. Got it up? So this is about which type of function today introduced it? Sample function. The main interest of explaining this is related to sample function, what do you call, choice function purpose I went here. Next, one more kind of, in this level only, we want to go for something like this. Clear up? Next, I am entering into, this is called one type of random distribution. Now I will go for permutations. Have you heard about permutations? Permutations means what? For example, Mississippi. Do you know Mississippi? Mississippi. In how many ways I can display this Mississippi? You need to apply NCR, NPR. In your 10th class, intermediate, some concepts are there. Most of them completed BTech. You have written MSET also. MSET also you have written. Okay, no problem. At least JEE mains you have written. Okay, nothing is written. 10th class studied or not? Yes, there it is available. There it is available. No problem. Still, if you don't know, no problem. I'm going to show, follow me. Now I'm going to take up. And you don't say, sir, still I don't know Python, sir. Then I'll drop you in the Begumpet railway station. Finally. Right. My dear students, now I'm moving to the further. Watch it. Import random. Import random as R. Everybody watch it. I'm going to tell you basic. Basic. LST is equal to R, I will write it. S is equal to R, something like this. Let me take basic one. 10 comma 20 comma 30 comma 40 comma 50 comma 60. Now R dot sorry, LST R dot shuffle. Shuffle. Have you heard about the word shuffle? Shuffle. What shuffle will do? Reorganizing the elements in the mutable object. So I will write it what here? LST. LST. So what shuffle is doing? It is shuffling the elements in the same place. It is shuffling the elements in the same place. So print of what? LST. R. Print of R, RST, UV, W, XYZ, that is not the correct. Print of LST. Print of LST. It is shuffling the elements of LST, keeping the elements in LST itself. So it is going to rearranging the elements. In what order it is rearranging, need not to worry about it. Again, if I go for shuffling it, again it is going to be available like this. Now, in how many ways I can arrange it? In how many ways I can arrange it? How many number of elements are there? 6 elements are there. For example, one of the possibility I can take, look at, I will write it. Nothing to worry for I in range of LN of what? LST. LN of what? LST. For example, LN of LST. Okay now? Now I am doing what? R dot shuffle of what? LST. LST. Print of what now? LST. Now I am going to show you here. See, these are the number of possibilities of rearranging my elements. For example, how many times I am arranging? Length times. How many elements? 6 times. Again you run it. Sorry. Again you run it. Again you run it. So it is going to give some different order. Again you run it. Again you run it. See this. This is going to give you some more different order. Similarly, it is a very regularly asking question. I am talking about a Python level random module. S is equal to what? Mississippi. Mississippi. You need not to count how many letters are available. How many times? Totally 12 are there. 0 to 11. 0 to, tell me how do you do? If I say R dot shuffle off, yes, it will give error. Shuffling means what? It is shuffling the data only in the mutable object. But str is called immutable, which I already taught to you already in the classes. So it is going to give you error. What is that error, please? str object does not support item assignment, which is one of the property of our immutable object, which I already explained in the Python classes. So this is not, shuffle cannot apply on what? str, bytes, and next range, tuple, set, frozen set, because these are all immutable nature is there. Next, dict also is called what? Keys, key you take it. Key is what? Immutable. Value of value is mutable. You cannot apply these things. On these things, you cannot go for what? Shuffling. And some people will be, dictionary is possible, you may think 10 1.2 comma 30 colon 4.5. Just I am showing you. See that it is called what? D, error. Not possible. This is your account. This is your balance. This is your friend account. Is friend balance. What is happening? Shuffling. His balance coming to you, your balance. Your balance is going to that balance. Allowed? Shuffling is not possible. So even S is equal to 10, 20, 30, 40. Also not possible, students. See, shuffle of what? Yes, also not possible. So not even one object of traditional Python objects not possible. Into, float, bool, and etc. are called fundamental data types, contains only one value, no question of shuffling. Rest of them, sequence type, list type, set type, and dict type, not possible to, except what? List. Except list, you cannot do any of the shufflings. Understand? Now my question is, this is a very regularly asking question. I said error is coming. Then how can I do this? Now you know the answer. Convert into what type? That's all. Convert into this now. I am taking. I am writing. Come on. L is equal to L1 is equal to list of yes. Now I am going to write it. Beautiful. Now I in range of len of L1. Len of what? L1. Take care, students. Now I want to shuffle. Which values I am shuffling? List values. R dot shuffle of L1. L1. L1 is getting what? You see. Print of what? L1. It is going to show you separate letters will come. Separate letters will come. These are called possibilities of that. I and I. S and S. But what is happening? P and then I. Different. This is coming like that, but I don't want. I want in the string format again. You already know. In my class, already you know. See, join. Beautiful. Good. So, coming to this. Don't do this. What you say? Print off directly. Dot what? Join of what? L1, L1. See the data. See the data. Are you getting or not? What is this now? How many times I am arranging my data? Length times I arranged it. Is it not called different combinations? Similarly, there is one more function. This is shuffling is going to give you what? Shuffling the data. Number of permutations are showing. Number of combinations are showing. But it is going to rearranging the data in where? L1 only. L1 only. The same thing possible even in where? ND array also possible. ND array also possible. This combinations I want. So I'm going to the new one. New one I'm going to take it. What is that next? I'm going to talk about examples on NumPy permutations. Permutations. I'm going to talk about permutations and combinations. Permutations and combinations by using what functions, mom? By using shuffle function and what? Permutation. Permutation function is there. Where is this function is present in numpy dot random dot. This is present in where? NumPy dot. It is present into NumPy dot permutation. Shuffle will do what? It will shuffle the elements and put it in the same place. That is in place only it will do. But what about permutation? It won't do any changes to original ND array object. It returns what? One of the combination to the left side variable. Getting or not? Both of them will arrange the combinations. But permutation will give you where? Rearranged order will be given to some other left hand side variable. It won't do the original change to the original object. But shuffle will do what? It will modify to the original array itself. I hope you are following. So coming to the point back, online students. So coming to the point of it, now I'm going to take up that kind of concept. Try to show you an example, ma. So these are all called a different type of concepts I'm covering, because in data science level, you just as far as coding of NumPy is coming, you have to feel that easy. But models, algorithms, they have to explain. Please refer this random permutation of elements. So NumPy level, come on, ma, read out now. A permutation refers to an arrangement of elements. Example, 3 to 1 is a permutation of what? 2, 3 and vice versa. Good. Not only one, but there are multiple permutations also. The NumPy module provides two methods for this. One is shuffle and one more is permutation. What shuffle I already said, it will rearrange the elements in the same array. What about the permutation? It won't rearrange the elements in the same array. It will reflect to the left side variable. Understand? If you want this facility, you go for it. If you want another facility you want, you can go for it. Shuffling arrays. Shuffling means what? Changing the arrangement of elements in place. That is in the array itself. Randomly shuffling the elements of array. From NumPy, import random. Import NumPy as NP. NP dot array 1, 2, 3, 4, 5. Shuffle of ARR. It is going to give you some different arrangement or not. So that type of example, you go to this. Come on now. Import NumPy as NP. Okay. A is equal to NP dot array of, so 10, 20, 30, 40, 50, 50. Now I'm going to say print of what? Original array, original ND array object is equal to comma what? A. Now I'm going to apply shuffle, rearrange the elements of, rearrange the elements of what? Rearrange the elements of which one? Elements of ND array. Elements of ND array. How do you do that now? NP dot shuffle of what? Yes, random dot. Exactly. So NP dot random dot shuffle off. What is this now? A. A. It is going to rearrange the elements in A itself. Print that now. Print that now. Shuffled ND array object. Shuffled ND array object. Now I'm going to say shuffled ND array object content. So what is happening? Is it rearranged or not? Again I'm going to say. Again I'm going to say. Again I'm going to say. In general, come on. For I in range of. For I in range of ln of what? A. Ln of A. Come on. I will say directly. NP dot. NP dot. Random dot. Shuffle of A. Print of what? A. That many number of times that rearrangements will be coming. Are you getting? That's all. This is related to something like this. You can go for a 2D array also, 3D array also, same thing you can apply. Understanding, students? Similarly, shuffling, never bother about 1D na, 2D na, that rearrangement we cannot expect in what order it is. But the thing is, it is going to be available at where? Same address will be coming. Following, students? So if you want, sir, I want to see the addresses also, sir, means you can see that address also. I am writing what, ma? ID of A. ID of A. What is happening? Random takes, okay, shuffle out, not in that way, ma. So I will take up, not in that way. A. You are getting that A now? So instead of that A, not in that place. ID of what? A. So A is equal to and ID is equal to dot format of A comma ID of A. ID of A. See that, students? Same ID. Is it a proper different arrangements or not? So because ND array object is mutable or immutable? Mutable object. You know na? Well, at the same address it is going to be. There is one more function called what? Permutation. Come on now. Shuffle method make changes to which array? Next, generating permutation of array. Generate random permutation of elements of the following. See that? NP dot array random dot. Yeah, this is also belongs to what? Random only. So by mistake I wrote here. What is this now? So here I wrote it. Here it is written NumPy dot what? Random. See how many random functions are available. How many random functions are available? Come to the point back. NP dot array of random dot what? Permutation of what? ARR. Then because of that only result is coming. I just want to go for taking this data. You try to understand. In this way, try to go to this place. By using which function now? By using which function? Permutation. NP dot. By using permutation method for rearranging elements. Rearranging elements. Are you following? Now, there I am going to take it. NP dot array of. Here I am going to write it. If we just write it only, range will come. NP dot I will write it. Here I am writing some X. Here I am writing some X. What is this now? See. What is this now? Original ND array object. Original ND array object is equal to comma what? A. Next is called what? Come on. Permutated ND array object. ND array object is equal to what? Comma X. Comma X. See that? So, yeah. Okay. So, ARR. This is called ARR. This is called ARR. You try to run this now. You are getting first element remains same or not? And the permutation function returns that elements into this place. I hope you are getting it. Getting up? So similarly, try to go for Any number of elements you take it. Now I'm going to take it. Here I'm going to take up something like this. Which one I'm taking, you just try to understand. Here I'm going to write it. This entire thing, you will write it. List of what? Some data I'm writing. Mississippi, I'm writing. Mississippi, I just wrote it. Convert it into what type? List type, ARR. And see this now. We are going to get some different combination. I got it. Are you able to get it, students? In general, this is my array. This is my combination. Here you try to get it. I will try to write something, students. You try to follow. Here I am writing for I in range of, come on, len of what? ARR. len of ARR. I will say here. Come to this place. Come to this place. What is this X is? Some data I got it. What is the next I'm doing? Print off. Print off. Come on. Print off. Some within that. Dot what? Join of what? A. Join of X. Join of what? X. Join of X. See that data? Are you able to follow? So converted into what? ARR. Original data remains same only. Even original data, if you want, you can take this. Only this X related I'm joining and then I'm printing it. Able to get, students? So permutation and shuffle. These are the very frequently asked questions. Are you able to get it? So next part, what is this combination is called? Permutations. If I have 10 elements are there, with the 10 different combinations, I want somebody ask, what you will say? For loop. LN. And you will call either what? Shuffle or permutation. So you'll get what? Different combinations, you will get it. Clarity is there? Or getting one topic, other topic, replacing? Random distribution. What is the function name? Choice. Uniform distribution. Rand uniform. Randian normal. Next, permutations. Functions, shuffle, permutation, choice, normal, random. These are all the functions in where? Random model. Random model is very important. Shall I move forward? Online students. So I hope this concept is clear. Random permutations of elements in this place. Now I am entering into next one. Another discussion I am going to enter. Another concept I am going to enter. Here I got it. Random dot. Just for your purpose. What is that now? Which function? Shuffle off. Next, what is the next? Random dot. Permutation. Permutation of ND array object. Here also what? ND array object. These are all NP dot, NumPy dot, NumPy dot. Next, one most wonderful topic again. Next, there is one more kind of concept called what? Difference between, and the concept is going to come on for you. And of course, it is a very easy. Let me introduce one easy. Flatten. Spell out. And one more is called ravel. Spell out. Ravel. Once again, spell out. Flatten and ravel. This is also regularly asking question. When do you go for flatten? When do you go for ravel? Suppose, of course, how simple it is, you see. There is a two-dimensional matrix is there. What is the order? Number of rows, number of columns. Suppose m into n. That m into n I want to convert into flatten the list. That is the one dimensional I want to prepare. Will you prepare it? Will you prepare? How? Size. When I print the dimension, it is printing 2. When I print the shape, it is printing 3, 3. When I flatten the list, number of elements should be 9. I already said in the class, A dot shape is equal to 9, I said. I already said in the class. Do you remember? I already said in the class 9, so that it will become what? One dimensional. So I will go for it. You already forget, no problem. You go on forgetting, I'll go on explaining. No problem, no issue. So I'm going to take up examples on flatten, flatten and ravel of what? NumPy, NumPy. Okay. See students, import NumPy as NP. A is equal to NP dot a range of a range of 9 dot what? Reshape of what? 3 comma 3 print of what? A print of what? A dot what? Endim. A dot what? Endim. Print of what? A dot what? Shape. Okay, A dot, no problem. A dot. Am I getting or not? What is the dimension? 2 dimension. Okay. Now I will print this A. Already you know A printed. You already know. It is called 2 dimension. I want to make it as what? Flatten. Flatten the list. How do you do that? A dot shape is equal to 9 comma. This I already said. Okay, spelling mistakes I'll take. Subjective tell me. Print of A and print of what? A dot endim and print of what? A dot shape. You see the answer now. Is it becoming flattening or not? Yes. So already we know that this is okay. That's well and good. Now today I am using something different. I am using something different. Same thing, same concept only. I'm trying to get like this. Same concept. Nothing change. We are using what? We are using which function? Flatten function. Flatten function. See that? Print this A. Now I'm going to write it. NP dot flatten. NP dot flatten or A dot flatten, I think so. A dot flatten. A dot flatten. You try to see what is the flatten. A dot flatten. What is A? Object. Of which object? ND array object. ND array object. ND array class flatten is one of the instance method. If you know whoops. ND array is a class. Inside the class, what is flatten? Instance method. How I am calling object name dot. If you don't know whoops, for example, your whoops is already whoops, for example. In list, L is equal to list of L dot append, L dot insert, L dot copy. Today, A dot flatten. A elements you flatten it. Flatten means what? Single list. Getting or not? Easy. Where it is available? You print what? Print of. What is this now? Dimension of what? A is equal to. What is the dimension? A dot what? Endim. A dot endim. Next is called what? Print of. Print of. A shape of what? Shape of what next? A is equal to comma what? A dot shape. You see that? What is happening? Come on. Dimension. Still it is containing what? 2 dimension. That means flatten function is going to return the output in the form of 1D, but still original array remains same. If you want the 1D to hold it, you go for what? X is equal to print of what? Content of X. Content of X is equal to comma what? X. Whose type also ND array only. Next what? Dim and then what? Shape, all of the same. Shape of X and dim of X. X dot ndim, X dot shape. So am I getting 1 comma 9 comma or not? So flatten function will convert Come on. Two-dimensional data into where? One-dimensional data. And storing that result into where? X. That X is also what type? ND array itself. Be careful. Now I am writing that indicates this row is becoming what? This is called one column or not? This is called column. Column become what? Row. Again, this is another column. This is another column. That is also becoming in the same row or not? This is 6, 7, 8 is also one column. That 6, 7, 8 also will become what? Complete row. And all the columns becomes what? In simple word, this is going to become something like that. All elements are like this. Now, be careful. Once again, I am going to say, nothing to get any confusion. One small parameter I am using today. One small parameter I am using today. Careful. What is this now? Print of what? Given array. Given array. Given array. Yes. Print of. Flattening now. I am writing inside of that. C I am writing. C I am writing. C I am writing. Don't worry about that C. Don't worry about that C. Are you taking one parameter here? C. Well, output is what? Output is what? Same as previous. Okay. Hold on. Come to the next term. Come to the next term. What I am writing here is F. Come to here is called F. See that. What is happening now? 1, 2, 3. What are these called? Column is becoming row. Another column becoming row. Another column becoming row. That is called column major order. C indicates column major order. Spell out. Column major order. Very, very important. All columns becomes what? Rows. It is a C style antaru. C style. Spell out. C style. There is a F style. F style. That is a Fortran. Fortran ane oka language. Because NumPy, when they are developing, they used C standards internally. In C standard, they are using C and F. What is that F stands for? Fortran style. Fortran is one language. Formula translation. Fortran. 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 Formula translation. Full form. C stands for what? Column major order. Columns will become what? Row. F. I am using F. What is that F? Columns becomes rows becomes what? Yes. Come on now. F I used it. F. What is that? See that. What is this now? Row, row, row. That row. First row element become what? Row. Next row, next row, next row becomes what? Like this. Next row, next row, next row becomes like this. Generally, student will do what? Reverse. What the even when I was explaining very long back, 6, 7 years back, column is becoming row ankunnan nenu. But when I see the documentation, C style and then what? F style. C style means what? Columns become row. F means what? What is this row? Zero, ma? 0th row, first row, second row. Become what? One row. What is this now? 0th row, 0th one row, and this also will become what? Low. Next, this is 258. Also become like this. First, keep both of them adjacent. This is 1, 2, 3, 4, 5, 6. And this is called what? 3, 5, 6, 1, 4, 7, 2, 5, 8. Different or not? How many types of flattens are there? Two types of flattens. Column major order flatten. Row major flatten. C stands for what? Actually column, no. Opposite is what? Row. This is called what? Row major order. Row major order. C stands for what? Row major order. Becoming row. And what is this F stands for here? Right. Are you able to follow? And even I said reverse or what? C stands for what? Right. Same. C stands for what? Don't think C. Myself said reverse. Huh? C meant for what? Row. Row. F stands for what? Column. Then documentation చూపిస్తాను మీకు. Don't get confused. Are you okay? Fine. By default what? C. C style. So how many styles of flattens? 2 styles. Go to once. Import NumPy as NP. What happens? Yeah, NumPy. NumPy as NP. Help NP dot flatten flatterer. What is my function name? So, okay, not that part. No problem. You come to this place. No issue. Object help I want. Here I will take it. I will get it this. Here I will get it. Rearranging. X is equal to what? A dot FLA flatten off. And help of what? A. Now see that. What is A? Madhubhavalo, what is A? ND array. That function ND array. That ND array function showing or what? So here, come on. C style. Column major order is what? Fortran style. What is this T represents? ND array. So it is nothing but T stands for what? Transpose of the array. If we look at, this is going to be like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is this. If I say A dot what? Flatten. Just to flatten. What is the answer? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is called which style? What style? C style. C style means what? Yes. C means actually column. You take reverse. Understand? Okay. Now you do, this is my given data. You know A transpose of? And F style I am talking, F style. F style is equal to transpose of A. What is the transpose of A? A transpose is equal to what? 1, 4, 7, 2, 5, 8, 3, 6, 9. If I do A dot what? FT of, what is the answer for this? Come on. 1, 4, 7, 2, 5, 8, 3, 6, 9. It is as good as of what? F dot FT of what in the bracket? F is equal to what? Transpose and then flat. Getting or not? Yes. So that is, how do you get the transpose? Simple. A dot T or NP dot what? Transpose of what? A. That will be transposed. I think you are following me. So go to the place. I hope you are understanding the concept of what? F and then what? C. So C stands for what? Row major. Rows row major order. Rows columns still 8th class, 9th class. Row major order. And row is a major order. F means what? F flatten with F is nothing but what? A transpose dot flatten. Are you following? So understanding, I think so. Flatten concept. Understood? Next concept I'm going to introduce. What is the next function? Ravel function. Clear? How many flattens are there? Row wise flatten. Yes. Very important. Next I'm going to say Ravel function. Careful. Take this. I'm going to take it. This data. Here you see. Under this, I'm going to take up given array A is equal to Got it. Now I'm going to take up Ravel A dot Ravel of. What is happening? You see, what is happening? 0, 1, 2, 3, 4, 5, 6, 7, 8. Also looking like what? Come on. Flatten only. That is which style? C style. C style. Print of what again? You see here, given array you see. What is happening now? It is going to print the same data or not? Now, this case, it is going to come something like this. Now I am going to write it. Now I am going to take up. In this case, you see, here I am going to write it. Some X you write it. Print of what? X. X. Of course, type of X is also, of course, I did not show you. That is also called what? End array. Now, if I come back to my concept once, here I am going to come to this place. I hope that there is a function name called what? So where is it? Flatten and what? Ravel. Once I will show you that concept and I'll move forward. Try to run this, try to understand. In NumPy, both flatten and Ravel functions are used to convert multi-dimensional arrays into one-dimensional array. Both of them are same. As you heard about a copy function and then view function, did you remember? That is used for what? 2D means 2D, 1D means 1D, 3D means 3D. But this flatten and Ravel is doing what? Everything converted into what? 1D. But one with owns the new data, once with owns the view. Once with owns the view. Who will owns the view? Ravel. Flatten will get what? New array. Okay, no problem. Try to understand. However, there are a few differences between these two functions. Number one, return type difference. Flatten function returns a copy of the array. That means this one. Here, flatten. Are you getting? A dot flatten of F, A dot flatten of C, X. I am holding into separate X. Separate X. Whatever the changes you do in X, that never reflect to A. Whatever the changes you do in A, they never reflect to what? It is exactly like a shallow flatten. Whatever the 3D, 4D, etc. is there, it is converted into what? 1D. Getting or not? Understand? And both of them contain same address or different address. You can print ID of X, ID of A, both of them are completely different. Have a separate, no base at all. No base. No base means what? No relationship between both of them. But initial content is going to be same. Now, when you come to Ravel, Ravel is not going to create what? Any new is not. It will hold the what? Original copy address only it can hold. That means if I do the changes to Ravel object, that Ravel object content is going to change what? Original, like a view concept only. View concept only. View will do what? Viewed one, original one are pointing to what? Same memory. Are you getting? But flatten will do what? Separate object. Changes will not reflect to each other. Like a deep copy, you can take in simple word. If you have the complete knowledge of that, copy view, shallow copy, deep copy, today nothing. Return type. Flatten function returns a copy of the array, while Ravel function returns a view of the original array. Whenever it is possible, whenever you are applying the Ravel function, it will get only what? View. Once view means what? If I change the original, view also will change. If I change the original array through view, original array also will be changing. A view is a reference to what? Original data. Whereas copy creates a new array with its own data. That is in the case of what? Return type. Return type. Are you following me? Next, performance part of it. Of course, it has its own advantage. If I do any changes, which one is doing very fast changes? Ravel. Why? One place only we are doing the changes. If I go for flatten, two changes has to do. It takes some time. Since Ravel returns a view whenever it is possible, it is generally faster and more efficient, memory efficient compared to pattern. Why? Single memory only created, which always creates a new array. Where, however, if, if a continuous array is required, flatten is safer choice. Means what? Separate array you require. Separate next array you need. Go for what? Flatten. If you want the same array to point, Ravel. This is I am just thinking in the form of what? Percentage, performance point. Next what? Modifying the original array difference. This is one difference. This is another difference. This is another difference. Modifying difference I am taking. Come on, tell me that. If modifications are made to the flattened or raveled array, the behavior differs. Changes to the flattened array do not affect the original array as it is a copy because it is a new copy. However, changes to the raveled array may alter the original array as it is a view referring to the same data. Getting or not? That example I am showing. Here an example illustrate these differences. Creating an array. NP dot array of 1, 2, 3, 4, 5, 6. Original array. ARR printed. Using what? Flatten. ARR dot flatten. I did not use F or C. What is the C style? Come on. Default style. Default style is what? C style. C style. What is this now? Come on. Row major order. Row major order. Row major order. Come on. What is this now? I am changing through what? Flattened. Flattened of 10. Modifying which array? Flattened array. Now I am printing flattened array. Using Ravel. AR.Ravel. Same thing. Raveled. Raveled is a view pointing to original only. Raveled of 0 of 20. Raveled array I am printing. Original array also I am printing. Raveled and original contain same. But flattened is containing something different. You got it out? So as it is, instead of typing the same thing, I'll try to keep it here. So here I am writing differences I am showing. Here I am writing differences between what? Flatten and Ravel. Important. Flatten and Ravel. So here see what is happening. Original array. Flattened array. I changed that. Raveled array 20. Again 20 changed or not? Raveled and original contain same. Flatten is containing like this, which is not reflecting to this place at all. Are you okay, students? So this is related to what? Ravel and flatten. Are you following, students? So, you can stand up. Mundu. Yes. Half an hour back, you went out of order, I think so. You're just sitting in the class like a doll. Like a, you're just sitting like a, something like a teddy bear. Look at, if you look at that side, what you will get it? What is the flatten? First, polka devasare. Spell out first. Don't fold the hands. Normally you stand. Spell out that word. Spell out. Different batch. Kada? Yes. Spell out first that word you spell out. Huh? If you look at other side, what will happen? Sit down. Puja. Sit down. Improve your career. Unable to spell out also. Are you following this? Now, improve. Python completion, no jobs will come. Open your notes and check it with other person notes of my class. So come to the point of it. Flattened. Getting or not? Next, come to the point of it. Original array, I gave the output to you. Same thing. Are you getting? So compulsory question, difference between flatten and Ravel. Both of them converts into what? 1D. Flatten will create a new copy, new address, modifications never reflect to original array. Ravel will convert any data of ND array convert into 1D, but Ravel will hold only view of that. Changes made to each other, Ravel and original array will reflect to each other. Got it? This is most important. Got it? Difficult? So what do you learn today? Random distribution, choice, permutations, that is in that place. Next is shuffle, permutation, Ravel, flatten. Now time is 10:56. I'm just feeling that 5 minutes back I came to the class. Just 5 minutes back. So much of time is completed. Next I will teach tomorrow what? Next I will teach you. This is my, see how much great content I'm going. Daily I will go into. See, 10, 20, 30. Look at 40, 50, 60, 70, 80, 90, 80, 90. What is this matrix is? 3 by 3. Now, swapping of columns. Swapping of columns. What is this column? 0, 1, 2. Write a program which will swap the columns of a matrix. 0th column should go to second column. Second column should come to first column. That is one thing. One more thing is called what? 0th row, first row, second row. First row will go to this place and then 0th row will come here. What is this now? Swapping of ND array elements. Swapping of ND array elements. 0 to column, row to row. And don't ask me your own doubt. Row to column to row. Because your doubts are so hi-fi, international doubts. If 3 rows are there, 2 columns are there, is it possible to change? That's why don't ask international doubts. You follow my doubts, subject doubts you follow. Are you following? This I'll tell you tomorrow. Next I will go to next tomorrow. Statistical operations I will tell you. Even I can teach you binomial distributions also, students. But whether you will hold it or every day or not, I don't know. But tomorrow I'll go for, after this concept is over, I'll go to concept called what operation? Statistical operations I'll go for. A max, A min, mean, median. Come on. Mode, మీరు చెప్పింది ఉండదు అసలు. Mode is not there. Standard deviation, variance, all those things. Okay, now? So mode is not there. If you type np.mode, error will come. Because whatever you say, that will not be there, 100%. So where is the mode is available, I will explain. That's why carefully I will go for it. Shall we stop? Right. Tomorrow class, swapping concept I'll tell you. Statistical operations I will tell you. So, okay, students, take care. All the best. Students, today time is over. Online students, today time is over. Online students, no doubts today. 10:59, no doubts. Online students. Tomorrow I will clarify your doubts. Online students. Thank you.